The Gobi Desert, with its lifelessness and harsh conditions, is the perfect place for all kinds of experiments, naturally first and foremost for greening it up. So much has been planted there, so much sand has been turned into oasis. In short, China is carrying out incredibly useful experiments and is actively fighting against desertification. However, that's not the end of what the Chinese are up to in the Gobi. Here's another spot that's also in this desert. Nothing special, just regular sand with a hint of sparse vegetation. The greening efforts haven't made it here yet. Then at some point, a complex like this showed up. At first, it looked like nothing special, but if you take a peek underneath, you'll see that the Chinese have dug a 919-foot tunnel, the beginning of what will eventually be a base with over 8 miles of underground tunnels. What's the mega project China's come up with this time? Let's figure it out. China's nuclear power industry started developing back in the last century. So by 2002, the country already had 5 nuclear power plants and 7 reactors with a total capacity of 4.5 gigawatts. What happened next? China as a whole began developing at an incredible pace, and nuclear energy wasn't left behind. By 2005, reactors whose foundations were laid back in the 90s came online. The total nuclear capacity jumped to 15 gigawatts. After another 9 years, China had 19 gigawatts of nuclear capacity. It might seem like just a 4 gigawatt increase, not that impressive, but from that point on, the country started ramping up its nuclear development at a faster pace. Year after year, the overall capacity kept growing, reaching 53.2 gigawatts in 2023. In other words, in less than 9 years, the figure nearly tripled. By the way, analysts say that it took the U.S., China's main competitor, almost 40 years to achieve the same level of growth. Do you think that's where the country stopped? Not at all. In the early 2020s, China rolled out a plan to build a whopping 150 new reactors over the next 15 years, aiming to hit a total capacity of 200 gigawatts by 2035. This ambitious goal will require investments ranging from $370 billion to $440 billion. But honestly, with all its mega projects, China probably isn't sweating these pennies, because if they hit that 2035 target, all that power could light up more than a dozen cities the size of Beijing. The real climax will come in 2050, when the country aims to ensure that 15% of its electricity production comes from nuclear power. Obviously, a nuclear power plant is a more efficient way of generating energy than alternatives like wind turbines and solar panels, which are much more developed in China. However, there's more to it than that. It's clear that China understands that the whole collection of dirty coal-fired plants is harmful to its country, so lately it's been actively pushing to replace that method of power generation with nuclear. 200 gigawatts of power, which the country plans to reach by 2035, isn't just a way to bring electricity to many cities, it's also a potential reduction of 1.5 billion tons of carbon emissions per year. By the way, this figure is higher than the combined emissions of the UK, Spain, France, and Germany. Those are some staggering numbers that show just how much pollution China's pumping into the air. China even has a plan for 2060, which once again underscores their overall push for nuclear development. By building new plants and reactors, they're aiming to replace their 2,990 coal-fired power stations. Unfortunately, just like every other energy source, nuclear power plants generate waste too. And that's where China's facing some challenges. Nuclear power produces low and intermediate level waste. This includes things like rags, clothing, metal reactor parts, filters, and pretty much anything that comes into contact with nuclear reactors. In Chinese nuclear energy, these two categories make up 99% of all waste, and the disposal process involves packing them into special containers and burying them at depths of up to 330 feet. Naturally, the Chinese are managing this quite well. They have several specialized facilities where low and intermediate level waste is stored and processed, but there's that third category, the remaining 1%, high-level radioactive waste, or HLW for short, which is a whole different story. This category mainly consists of spent nuclear fuel. The catch is that it's extremely radioactive and remains that way for tens or even hundreds of thousands of years. It's basically the same approach as with less dangerous waste, just bury it. But in international practice, the standard way to handle HLW is to bury it in stable geological formations 1,640 to 3,280 feet below ground to keep it isolated for over 10,000 years. Overall, it's way more complex than dealing with other waste types. That said, something has to be done about it. And no, the Chinese didn't just start paying attention to this when they suddenly had a bunch of reactors. Anticipating the problem, the Chinese started looking for a suitable location all over the country back in the 80s. However, during the research, it quickly became clear that the ideal region was Inner Mongolia. Since the 90s, they've drilled around 100 deep wells there, which took an enormous amount of time and required a tremendous amount of resources and effort. Just imagine, the cores extracted from those wells added up to a whopping 37 miles in length. The Gobi Desert was also part of the research. The study showed that this barren land isn't just a testing ground for large-scale Chinese greening projects, it's also a place that could potentially save the country from high-level nuclear waste. Near the city of Jiuquan in Gansu Province, the Chinese laid the first stone back in 2021. Here's what that spot looked like. As we said, dealing with high-level radioactive waste means a lot of digging, or drilling to put it in modern terms, so every Chinese worker knew another big job was on the horizon. And sure enough, that same year they got started with the usual Chinese drive to set a bunch of records. The tunnel boring machine Beishan 1, 330 feet long and 23 feet in diameter, has arrived at the site. By the way, it's the first machine in the world designed for tunnel drilling at a steep angle in hard rock, and it started drilling the underground ramp of the laboratory. This is where the construction of a $300 million underground structure called Beishan began. So far, the machine has reached a depth of 918 feet. Does this mean they can now start dumping high-level radioactive waste underground and live happily ever after, further developing the nuclear energy sector? No, this is just the very beginning. This is a real megastructure. Here's what it's supposed to look like according to the plan. The tunnel that's already built is just the entrance. Actually, one of the entrances, because there will be 3 vertical tunnels, so the tunnel boring machine still has a lot of work ahead. In total, the Chinese have planned to build an underground complex with a structural volume of 18 million cubic feet, which includes 8 miles of tunnels. It's said to be the largest underground facility of its kind in the world, all in the Chinese style. As you can see, China doesn't plan to limit itself to just underground work. There will be plenty to do above ground too. The surface structures will cover 610 acres. Various administrative buildings and everything else needed to keep the underground facility running will be located there. The partially above-ground section of the base is already built. It's a few buildings where some research is already taking place, plus a certain number of workers are living there. However, there's still quite a bit to go before the construction is fully completed. The people in charge of the project say that the full completion of the construction is planned for 2038, after which the ground and underground base will take the form that was shown with computer graphics. And here comes the question. Why build such extensive infrastructure underground if all you really need to do with radioactive waste is bury it deep enough? Well, in theory, it could be done in this underground structure because the site for the facility was chosen for a reason. The researchers who worked on finding a suitable spot for the high-level radioactive waste storage discovered that a solid granite mass lies here, covering an area roughly equivalent to half of Beijing. As the head of the search team stated, he had never seen such a solid rock formation. The more solid the structure and the fewer the cracks, the better it serves as a natural barrier for highly radioactive waste. After that, Chinese and foreign experts visited the site and confirmed the head of the search team's conclusions. Beishan preliminarily offers the best overall conditions in the world for containing the harmful effects of especially dangerous waste from China's nuclear sector. However, despite all this, even after the completion of the entire underground above-ground project in 2028, the Chinese haven't planned to dump the high-level radioactive waste there. After that, research will begin to show whether the site is really suitable for storage, and these studies which will be conducted won't take just 1 or 2 years or even 10 years. They're planned to last all the way until 2050. If all the preliminary calculations are confirmed, then construction of the underground storage will start next to the lab in 2050, where all the most dangerous nuclear waste from China will be stored. But don't think the lab will turn out to be a pointless waste of time and money in case the site is eventually deemed unsuitable for the storage of high-level radioactive waste. The structure will become the largest underground lab with the most functions in the field of high-level radioactive waste disposal in the world. To put it simply, it's a very useful facility for many countries, a kind of experimental field. China's already exchanged a lot of information and cooperated with more than 10 countries and regions, as well as with the International Atomic Energy Agency. In addition, over 100 international experts have visited Beishan for research. In 2024, Beishan hosted an IAEA underground research facility and geological disposal repository design and construction technology training course. organized by the corresponding Chinese institute. 45 experts and national representatives from 17 member states, including France, Sweden, and South Korea, took part via video conference. In general, you get the idea. Even if the Chinese have to find a new place to store the HLW, thanks to the research at Beishan, they'll probably do it faster. Also, the whole world will benefit. The words of the head of the search group who's currently working in Beishan fit perfectly here. The underground laboratory belongs not only to China, but to the whole world. This means that many other countries will also gain knowledge about HLW storage. And if you think the Chinese will stop there, well, no. If you look at this headline, you might think that some truly unbelievable things are happening in China. That whole bunch of equipment you see on your screen is what they call an artificial sun. If we're talking technical terms, it's the Experimental Advanced Superconducting Tokamak, or EAST. Tokamaks, put simply, are setups that hold gas turned into plasma at temperatures over 150 million degrees Fahrenheit. It's kept in place using magnetic fields. But why go through all that trouble? To carry out controlled nuclear fusion, basically the managed merging of atomic nuclei, which has huge advantages over nuclear fission, the usual method for generating power in nuclear plants. During nuclear fusion, a massive amount of energy is released, 4 times more than in the nuclear fission reaction that humanity currently relies on. Nuclear fission requires uranium, and some estimates suggest we've only got enough of it left for the next 150 years. In nuclear fusion, deuterium and tritium are used. The former is practically limitless on our planet, while the latter is artificially produced, and we can make plenty of it too. As for the issue of radioactive waste, which is a big deal worldwide and especially in China, there's way less of it with nuclear fusion, and it doesn't last nearly as long as it does with regular fission reactions. In short, developing nuclear fusion is where humanity's headed, and with its EAST project, China has already made some serious strides. In 2016, the artificial sun became the first tokamak in the world to keep plasma going for over a minute at 90 million degrees Fahrenheit. Then in 2018, it hit the milestone of about 180 million degrees Fahrenheit, and in 2023, EAST made history again, producing a steady plasma wave that lasted 403 seconds. The latest achievement came in 2025. EAST smashed its own record, sustaining plasma for 1,066 seconds. It's a huge step forward for China and the entire world, but Chinese scientists aren't rushing to celebrate. They understand there's still a lot more to be done, which will require special reinforced walls made of unique materials capable of withstanding conditions not typical for Earth. This could take a lot of time. But the Chinese aren't too worried about that either, because the China National Nuclear Corporation, or CNNC, says that China plans to build the first industrial prototype of a fusion reactor by 2035 and then make this cutting-edge technology available for large-scale commercial use by 2050. But that's still just a plan for now. Meanwhile, there's already some advanced tech for nuclear power, ground-based small modular reactors, which China was the first to put into commercial use. Regular nuclear reactors are incredibly bulky systems, and setting them up is a complicated task that can stretch over a long period of time. For instance, the IAEA says that as of 2022, the average time to build a nuclear reactor from the start of concrete pouring to grid connection was 247.7 months, or 20.6 years. After those calculations, in 2023, Vogtle 3 opened in Georgia, USA, taking 121 months to build, and in 2024, Vogtle 4 was completed, taking 125 months. As a result, the average construction time decreased, but it's still a lengthy process. If you need to power a specific area in a relatively short time, traditional nuclear reactors and the infrastructure they require just aren't going to cut it. Plus, those reactors take up a lot of space, making it either difficult or downright impossible to set them up in areas with challenging terrain. Say hello to Linglong 1, now in the process of being launched in Changjiang County, Hainan Province. It doesn't come with all the drawbacks of its traditional counterparts. The main module of this Chinese-developed reactor, also known as ACP-100, combines the high-pressure reactor vessel, the steam generator, and the main pumps, eliminating the need for a primary pipeline, which significantly cuts down the time required to build the reactor. Plus, other modular elements such as the steel and concrete containment structures also don't take long to install. For example, the operation to lift and install the outer shell weighing 550 tons took 1 hour and 38 minutes. Yes, there were 6,000 workers on the site, But here we focus on the fact that Linglong 1 is an innovation, and the whole process is a test of how everything could work. The rest of the construction didn't take long either. The first tons of concrete for Linglong 1 were poured in July 2021, equipment installation began in December 2022, and the main internal reactor building structure was completed in March 2023. Yes, the reactor still hasn't been fully commissioned, but the expected year for this long-awaited event is 2026, so it'll take only 5 years in total. The advantage in speed of construction's clear, and it's worth noting that this is a test project, so in theory, the Chinese could build similar Linglong 1 units even faster once they get the hang of it. However, the Chinese modular reactor won't be able to compete in terms of power with its counterparts. Linglong 1 delivers 125 megawatts and can produce 1 billion kilowatt hours of electricity annually, which meets the needs of 526,000 households and reduces CO2 emissions by 880,000 tons, or the equivalent of 7.5 million trees. The Vogtle 3 and 4 units in the U.S. generate 3,400 megawatts, which is way higher, of course, but the relatively low power of the Chinese reactors balanced out by the fact that it's easy to scale up. In theory, one Linglong 1 could quickly turn into a station with many more reactors like it. Well, we'll just have to wait until there's at least one modular nuclear reactor in every corner of China, and all the waste from it will be properly handled, and someday it'll get upgraded to a fusion reactor. Sounds like something impossible, but the Chinese can do anything, right?